Hello again. In this video, I will continue to my review session for final exam. This video will be a review from chapter 5. It's about trigonometric functions, okay? All right, let's continue. As I did in the previous video, I'm working on the final exam review I created on Alex, okay? I did the first 5 questions. I solved the first 5 questions in the previous video. Now, in this video, I will continue the next 5 questions. All right. Okay, find cosecant, cosine, and tangent on this triangle. Cool. Cosecant is 1 over sine, right? So, but wait a minute. So normally we are missing a side, right? We don't have this side here. So let's find first this part, okay? And to do so, I am gonna use Pythagorean theorem, right? So let's call that side x. X squared plus 9 squared is equal to 10 squared. X squared plus 81 is equal to 100. X squared is equal to 100 minus 81. So x squared is equal to 19. X squared is so x is equal to, sorry, not x squared, but x. X is equal to plus or minus root 19, right? But this distance cannot be minus, so x is actually equal to root 19. Okay. Now that the side adjacent to theta is root 19, so cosecant is 1 over sine. Sine is, remember, opposite over a hypotenuse. So I'm going to flip the sign. So normally sine theta is actually opposite over hypotenuse. So 9 over 10. That's why cosecant will be, cosecant theta is 10 over 9. Just flip the sign, okay? All right, what about cosine theta? Cosine is adjacent over hypotenuse. So cosine theta is actually equal to, adjacent is root 19 over 10, this hypotenuse. Lastly, tangent is opposite over adjacent, right? So tangent theta is actually equal to opposite 9 over adjacent root 19. Let's rationalize that guy. 9 root 19 over 19, right? Just multiply top and bottom by root 19. Okay, let's put those answers. So 10 over 9 for cosine. I need root, right? So I need root. Root 19 over 10. And for tangent, I should have 9 root 19 over 19. Let's check our answers. Correct. All right. Let's move. Let's go to the next question. Determine the quadrant in which the terminal side of theta lies. Okay. This is a nice problem. I'm sure that you like it. So secant should be negative and sine should be negative either. Secant is 1 over cosine, so we can consider cosine. So cosine is negative. Let me throw here. Cosine is negative here and there, right? 2 and 3. But sine should be also negative, so it is quadrant 3. Okay. So for the first one, it's quadrant 3. And for the second one, cosine is negative and cotangent is positive. So cosine is negative, again, second and third. Cosine is negative, second and third. Cotangent is positive, which is third again, right? Cotangent is positive. All students take calculus. So the sign of cotangent and tangent are same, right? Quadrant 3 and quadrant 3. Let's check our answers. Correct. Okay, nice. Let's move to the next one. Okay. Let negative 4,7 be a point on terminal side of, find the exact value. Okay, this is a nice problem. I like this type of problems. Let me make a new page. Okay. All right. Okay. What was the formula? Let's remind you those formulas. If we have a point xy on a on the xy plane, right? So let me remind you those formulas: xy, but this is not on the unit circle. This can be on any circle with radius r, okay? So we have, why are writing like that? Radius is equal to r. Then x is equal to, actually, maybe I can write this way, sorry. Cosine theta is equal to x over r. Sine theta is equal to y over r, right? And on the unit circle, r is 1, so cosine is x and sine is y, right? Okay, so we have x is -4. X equals -4. Y equals 7. So how can I find r? From Pythagorean term, right? X squared plus y squared is equal to r squared. X squared is -4 squared plus, this is 4. 7 squared is equal to r squared. -4 squared is 16. 7 squared is 49 is equal to r squared. So what is 16 plus 49? 65, right? 65 is equal to r squared. R is equal to plus or minus root 65. 65, not 69, 65. But of course, a radius cannot be negative, right? So r is equal to root 65. With having that, cosine is x over r, right? So cosine theta is x over r, -4 over root 65. Let's rationalize it. -4 root 65 over 65. Secant is 1 over cosine. So just flip the cosine, right? And I can flip the first part because when I flip the second part, I will end up with the radical in the denominator, which we don't like it, right? Let's flip the first part. If I flip that guy, I will get root 65 over -4, okay? And cotangent theta, cotangent is cosine over sine, right? So it's x over y, so it's x over y, which is -4 over 7. Sorry for my bad handwriting. Okay, so let's put the answer. Cosine is -4 root 65 divided by 65. Next, secant is root 65 divided by -4. By the way, you can put a negative in front of the root 65. It will not change the answer, right? And cotangent is -4 over 7. Let's check our answer. Correct. All right, let's move to the next one. Let theta be an angle in quadrant 3 such that cosine is -12 over 13. Find the exact value of cosecant and cotangent theta. Okay, so we are going to use the similar. Okay, let's make another page for this problem. Okay, so again, cosine is x over r, right, from the previous question. So cosine theta is x over r. It is -13 over 12, -12 over 13. R can never be negative, so x is negative, right? X is -12, r is 13. Okay, cool. It's good to know that. Find the exact value of cosecant and cotangent. Okay, we need to find what y is, okay? So let's find y. X squared plus y squared is equal to r squared. -12 squared plus y squared is equal to 13 squared. -12 squared is 144. 144 plus y squared is equal to 169. 69. So y squared is equal to 25. Y is equal to, again, plus or minus 5, right? But which one? To decide which one, the critical information is the quadrant, right? It's quadrant 3. And on quadrant 3, remember the y should be negative. So y is also a negative, okay, number. Y is negative 5. Great. Let's find cosecant. Cosecant is 1 over sine, right? So let's find sine. Sine is y over r. Come on. So y over r is negative 5 over 13. And to get cosecant, just flip it, right? So cosecant theta is 13 over negative 5. Again, sorry for my bad handwriting. Cotangent is, remember from the last problem, x over y. X is negative 12. Negative 12 over negative 5, which is 12 over 5, right? Okay, let's put the answers. For cosecant, this is 13 over negative 5. For cotangent, it is 12 over 5. Check it. Correct. Cool. All right, let's move to the last one in this chapter. Actually, it has the final exam review has 30 problems. The first 10 is from chapter 5, second 10 is from chapter 6, and the last 10 is from chapter 7. Let theta be an angle in quadrant 4 such that tangent is negative 4 over 3. Similar problem, right? Okay, let's make a new page first of all. Now, okay, tangent is y over x, right? So tangent theta is y over x. This is negative 4 over 3. So, and quadrant 4, right? And on the quadrant 4, y is negative, x is positive. That's why y is actually equal to negative 4. X is equal to 3. And we need to know what r is, right? And again, we are going to use the Pythagorean theorem for r. So r squared is x squared plus y squared. R squared is 3 squared is 9 plus negative 4 squared is 16, which is 25. So r is plus or minus 5, but radius is always positive, so r is 5. Cool. Similarly, what is cosecant? What is cosine? Cosine is x over r. So cosine theta is x over r, 3 over 5. We got it. Cosecant will be 1 over sine. And sine is, let's find sine first. Sine is y over r, negative 4 over 5. But to get the cosecant, the thing we need to do is just flip it, right? Flip sine. 5 over negative 4. Negative 4. Okay, let's plug the answers. 3 over 5 for cosine. 5 over negative 4 for cosecant. Let's check the answer. Great, it's also correct. So this is end of this video because I finished all the problems from chapter 5 in the review, final exam review on Alex. In the next video, I will continue to do review, but this time from chapter 6, okay? All right, so see you in the next video.